All right, so in this video, this is supposed to be a short video on how to use the reduced echelon form feature on the TI-84. So the main ideas of what we're going to cover in this video is that we're going to translate a system of linear equations into an augmented matrix. Now, RREF stands for row reduced echelon form. We're going to have our calculator give us that row reduced echelon form. And that row reduced echelon form of the equations is going to be equivalent to the equations that we originally had. So this row reduced echelon form is going to give us an easy way to find solutions to a system of linear equations. Now, this idea for us came up when we were using partial fractions. If anybody else is watching the video, that's fine as well. But this came up using partial fractions. And in that partial fraction section, our example 3 yielded this system of linear equations. A plus B equals 1, and 3A plus 2B equals 1. Now, this is already set up in a way that yields a nice augmented matrix because we have our variable terms on one side equaling our constant terms on the other side. We want this set up if we're going to use the augmented matrix. And specifically, we want our variable terms to be on the left and our constant terms to be on the right. So this is all set up the way we want it to be. Now, when we write down our augmented matrix, we're going to have one column be the coefficients of our variable, in this case, A. One column be the coefficient of our variable, in this case, B. And then we'll have an equal symbol and then our constants. So this is why we want the constants on the right, so that in the augmented matrix, the constants are on the right. So each row of this matrix is going to represent one of the equations, and each column is going to represent either a variable or the constants. So this is my augmented matrix. Row 1 is going to be 1 plus 1 equals 1. So 1A plus 1B equals 1. And then 3A plus 2B equals 1 represents my second row. Now, the big part of what I'm going to do here is essentially take that and have my calculator do the RREF. So row reduced echelon form of that matrix on my calculator. So here's how we do it. The first thing that I need to do is I need to put the augmented matrix into my calculator. The way I do that on the TI-84 is I go into the matrix menu, which is right here on that X inverse. Now, when you are in the matrix menu, you're going to have a couple of options. We want to put the augmented matrix in. So we want to edit one of these matrices. Doesn't matter which one, but I'm going to choose the matrix A. Now, my augmented matrix has 2 rows and 3 columns. So it's a 2 by 3 matrix. And just like we did earlier, when I wrote that, 1, 1, 1 was our first row, and 3, 2, 1 was our second row. In order to get those numbers, again, you just kind of use the arrow key to scroll around and then plug in the numbers and hit enter. So when I'm trying to plug in this value here, I just hit 3. This value, as you can see, is the 2, 1 entry of the matrix. That means it's in row 2, column 1. That numerical value is 3, hit enter, and then again, use those arrows to scroll around, meaning the arrow is on the right here. So now I have my matrix entered into my calculator. So I'm going to go back to the home screen by just hitting second and then quit. And then I'm going to go back to that matrix menu. So second and then the matrix. In order to get the row reduced echelon form, I need to be in the math section. So I push the right arrow here, over to the math section, and then I go all the way down to RREF. Now you can use the arrow to go down, or you can, if you wanted to start at the top, you can actually, it's a little bit quicker to push the up button. And then that takes you all the way down to the bottom. So if I'm at the very top and if I hit up, that takes me all the way down and I see RREF. So I'm going to do the RREF, hit enter, and then I'm going to go back into the matrix menu and tell it to row reduce echelon form, put A, my augmented matrix, in row reduced echelon form. So enter the names, it'll say A, I just hit enter, and then I close my parentheses by hitting the parentheses. So row reduced echelon form of A becomes 1, 0, -1, 0, 1, 2. So row 1 is 1, 0, -1. Row 2 is 0, 1, 2. Therefore, the row reduced echelon version is, like I said, 1, 0, -1, and then 0, 1, 2. This is kind of ideal because we really want this matrix in the first kind of 2 rows and 2 columns to look like the identity matrix. That is, we want it to have 1s on the diagonal and 0s elsewhere. If we have that, remember this matrix represented coefficients of A and B and my constant. Well, this one also does that. So this first row says 1A plus 0B is equal to -1. And since 0B is there, that eliminates the B. It basically says just A is -1. The second row is telling me 0A plus 1B is equal to 2. Or in other words, it tells me B is equal to 2. Therefore, A is -1, B is 2, is the solution to this system of linear equations. If you want to check that, you can plug it back in. And if I plug in A of -1, B of 2, -1 plus 2 does in fact give me 1. 3 times -1 plus 2 times 2 also gives me a +1. So this checks out, and therefore the solution to the system is when A is -1 and B is 2. Now, obviously, I've done this with A's and B's, but if you did this with X's and Y's, it would work in the exact same manner. We just change the name of our variable. So whatever we use as our variable is perfectly fine, or I should say whatever we use for our variables are perfectly fine. So again, I used A and B in my examples. Let's do another. When we did example 4 from my partial fraction section, we came up with these two equations, a plus b equals 0 and negative 6a minus 2b equals 7. So I'll show you how to do that on the calculator. Now, the first thing I have to do is to create the augmented matrix. Once again, this is nice and lined up. If at some point you did have something like this, if it said A equals negative B, then you'd want to add B to both sides. And make sure that your variables are on the left-hand side and variable A is sort of lined up above the other variable A in the other equation. Your variable B is lined up above the variable B in your other equation. And your constants on the right. So variables on the left, constants on the right, variables lined up. Then we can pull off the coefficients. 1, 1, 0 is what the first row is going to be of my augmented matrix. The second row is going to be negative 6, negative 2, 7. And then I want to row reduced echelon form this augmented matrix. So we've done this. Our previous example is on there. This time, again, we go into matrix. I'll use the same A. Remember that if I'm trying to put in the various things, I need to scroll over to edit. This augmented matrix is 2 by 3. We get 1, 1, 0. I'm just typing in the numbers and hitting enter. 1, 1, 0. And then negative 6, negative 2, 7. So that's my new matrix A. I'll go back to the home screen. Once again, I go into the matrix menu and then math. I like to hit the up arrow to get to my RREF. You can also hit the down arrow, doesn't matter. But letter B there is my RREF. And then second matrix, by second matrix, I just mean you have to hit the second button to get to the matrix menu. And then I want to input matrix A. That's where my augmented matrix was. So I just hit enter at A. And this time I find that the row reduced echelon form is 1, 0, negative 1.75, and then 0, 1, 1.75. So there we are, 1, 0, negative 1.75, and second row is 0, 1, and then positive 1.75. I want to say two things here. The first is this tells me that the solution is A equals negative 1.75, and B here would have to be a positive 1.75. Like I said, it's really nice when we get this identity matrix here. In our class, we'll always end up with the identity matrix, but there are certain times where row reduced echelon form doesn't lead you to this nice 0, 1s matrix here. But that's what we get as our answer. Now, just as a note, if you didn't like decimals, you can, in fact, use your calculator to um, translate those into fractions, all you have to do is hit math and then translate into fractions. That's number one here. You can hit either the number one or enter. I'll hit enter. So this is going to translate my answer into a fraction form. That means every number in this matrix is going to turn into either a whole number, an integer, or in my case, it's an improper fraction. So 1.75 is 7/4. Negative 1.75 is negative 7/4. If you want a mixed number instead of an improper fraction like that, then what you do is you change the mode and the fraction type on your mode. I have my fraction type set at improper fractions, but if you want mixed numbers, you just have to set your fraction that way in your mode section. And then now, if you go in again and let's go out a little bit, hit the math menu, fraction, now you'll get mixed numbers instead of improper fractions. For my class, the decimals were just fine, so I left it as just decimals. So that's the final answer there. A is negative 1.75, B is positive 1.75. And if you want fractions instead of decimals as the answers, you can go ahead and do that as well. I'll do one more example with two equations and two variables. So this was example 6 that we ended up with from the partial fractions section. We got A is equal to 4, and then 3A plus B is equal to negative 5. Now, this one, obviously, by hand, it's very easy to solve because we know A is 4. We can plug that in and solve for B. Again, very easy to solve by hand if you'd like, but this does point something out that feature out of our augmented matrix that I want to show. So if we have these two equations and we want to create an augmented matrix, then coefficient of A is 1 in this first equation. We don't have a B, and therefore we set the coefficient of B as 0 in that first equation. So that first equation, when I write in the first row for my augmented matrix, the first equation is going to force me to write 1 as the coefficient of A, 0 as the coefficient of B, and 4 as my constant. And then 3, 1, negative 5. So if we don't see a B in our equation, we write a 0 as its coefficient in the augmented matrix. Let's go ahead and do that on our calculator as well. So what I'm going to do once again is go to the matrix menu, edit matrix A, 2 by 3. We had 1, 0, 4 as the first row or first equation, and then 3A plus B is equal to negative 5. That was 3, 1, negative 5 for my second row. Now you'll notice that earlier I was doing RREF, and you can still, if you want to, go back into the matrix menu and then pull up your RREF. But once you've done this a number of times, it's easy just to hit second and then the enter. And then that gives you the line above. If I hit second and enter again, that gives me the line above that. And if I hit second enter again, that gives me the line above this one, which was just the row reduced echelon form of A. So row reduced echelon form of A, and it's going to use the new A that I just put in, is 10401 negative 17. So you can use second enter if you'd like to not have to go back to the matrix menu every time you want an RREF. So if you do a bunch of these in a row, then you can do that. So there it is, 104. We knew A was going to be 4, and 0, 1, negative 17. If we'd have plugged in 4 here and solved for B, it would have given us negative 17. We would have seen that easy. So my solution is that A is 4 and B is negative 17. And that's it. So that's how you use your calculator in order to solve these systems of linear equations where we have 2 equations and 2 variables. So a natural question is, what would happen if we had more equations and more variables? In particular, what would we have if we had 3 equations and 3 variables? Now, this came up in a couple of examples in the section on partial fractions that we did. So in example 5 of my partial fractions stuff, we ended up with A plus B plus C equals 5, negative 2B plus 2C equals negative 12, and negative 4A equals negative 12. If I'm going to set this up and use the RREF feature of the TI-84 to solve this system of equations, then it's pretty straightforward. I just have to have a bigger augmented matrix now. Since I have 3 equations, I'm going to need 3 rows. And since I have 3 variables, I'm going to need the 3 columns for each variable plus a column for my constants on the right-hand side. So I'm going to need 4 columns in total. This first equation, A plus B plus C, we'll use A for the first column, coefficients. So A plus B plus C equals 5, means 1 plus 1, 1A, 1B, 1C added together is equal to, on the right-hand side, 5. Again, we want all of our variables to line up. We want our constants to be on the other side of the equation, and we're going to put those on the right. Now my second equation has no A, so I put a 0 in for that. Negative 2B, a plus 2C, and is equal to negative 12. My last equation has negative 4A, there's no B, there's no C, and that's also equal to negative 12. So this is the setup for the augmented matrix. And then we utilize our calculator in the same way we did before. So in this case, what we're going to do, let me turn down the brightness just a bit. And in all cases, we're going to go into the matrix menu. We're going to pick one matrix. Now, it doesn't matter if I pick the matrix A or B or C. Since I have been picking matrix A, I'll continue that, but we want to edit that. This matrix has 3 rows and 4 columns, so I make sure that I change the matrix to having dimensions 3 rows and 4 columns. It's 3 by 4. And then we plug in our numbers. 1, 1, 1 equals 5. 1a plus 1b plus 1c equals 5. Then I got 0, -2, +2, -12, and then -4, 0, 0, -12. So that's the augmented matrix that we had earlier. Now we're ready to go to the home screen. I can go back into the matrix menu by hitting second matrix menu, scroll over to the math, and go to RREF. Then back into the matrix menu. We used our augmented matrix as matrix A. And there we go. Notice again, I get this nice, the left-hand side of this is really nice. 1's on this diagonal, 0's elsewhere. And then the right-hand side now is 3, 4, -2. So that's my, that is the row reduced echelon form of that matrix. I get a nice 0s, 1s matrix. That's the identity matrix. If you've taken any classes that deal with matrices, you know that. So 3, 4, -2. And essentially what that means is that in this case, A had to be 3, B had to be 4, and C had to be -2. You can plug those in to my original equations and see if they do in fact work. For instance, this first equation, if I add all 3 numbers up, they should give me a +5. If I take -4 times A, it should give me a -12. If I take -2 times B plus 2 times C, it should give me a -12 as well. And if you did that, you'd find that it does work in all 3 of those cases. This solution works in all 3 of those cases. I'm going to do one more example. And again, this example was example 9 in the previous section. So we're going to solve this using RREF and the TI-84. We had A plus B equals 0, -B plus C equals 1, and A minus C equals 3. You can solve this by a number of methods, but the RREF and the augmented matrix is a pretty nice method to use. I'll do this fairly quickly. So my first equation is going to give me 1, 1, 0, 0 as the first row of my augmented matrix. My second equation gives me 0, -1, +1, and then another +1 as the second row of my augmented matrix. And my third equation is going to be 1, 0, -1, 3. So as the third row of the augmented matrix. So 1, 1, 0, 0, 0, -1, 1, 1. Again, this is coefficients of A column, coefficients of B column, coefficients of C column, and then the constants on the right-hand column. So doing that gives me the correct augmented matrix. And now I use my TI-84 to put that in row reduced echelon form. Now I just did a row reduced echelon form of matrix A from earlier. So I'm going to do that again. Go back into the matrix menu. I'll edit my matrix A. It is 3 by 4, so nothing's going to change there. And then, like we said, 1, 1, 0, 0 is the first row. Let's scroll in a little bit so we see it a little bit better. 0, -1, 1, 1 is my second row. My third row is going to be 1, 0, -1, 3. And then I go back to the home screen by hitting second quit. We can do the RREF of A. One easy way to do that is, again, since I already had it up there, I just do second and then the enter key. That'll give me the entry that was previous to this. So in this case, that's again the RREF of A. And since my A is changed, it'll give me a different matrix from before. So my A is changed now. Now I get 1, the identity matrix on the left, and 2, -2, -1 on the right. So that is the row reduced echelon form of my augmented matrix. You can always go into the matrix menu and then scroll to RREF and then go back into the matrix menu and pick the matrix if you'd like. But again, second enter kind of gives you a nice way, if you've done a lot of RREFs, to keep doing those. So that's the idea of how we use our calculator there. So let me write that down. Again, identity matrix on the left. And then in this case, 2, -2, -1 is my right-hand column. I'm sorry, -1. So that means A is equal to 2. That's what I get from the first row of my row reduced echelon form of the identity matrix. My second row gives me B is equal to -2. And my third row gives me C is equal to -1. And you can plug those all in here to my 3 equations and see that you get true statements in each equation. So you can see that this is the correct answer. So that shows you how you can use your calculator to solve systems of linear equations using the RREF and the matrix features on your calculator.